Only for your own question here. I welcome all the students for this coaching, GATE coaching class, sponsored by AICTE PRERANA, organized by Erode College, Tamil Nadu. My name is Vijay Anand, assistant professor in the Department of Electrical and Electronics Engineering from Erode College, Tamil Nadu. I'm going to handle the subject power system analysis. In this session, we'll see about the formation of fibers matrix by two group factor. Before going to the topic, what is admittance and what are the uses of admittance that can be seen there? In generally, the power system has two elements, that is admittance and impedance. Generally, the bus admittance Y and Y bus impedance is a matrix or two impedance network matrix which finds the applications in many power system planning and operation planning studies. Where Y bus matrix finds application in load flow, optical load flow, even in stability analysis. Whereas in its bus matrix finds the application in subset analysis. These are the two elements, main important elements to find out the some of the fault occurring on the power system. In this way, we are going to see about the Y bus parties. Let us see in this diagram the formation of Y bus by two rule method. In this first diagram, they are that is we are considering a three bus system. That is three in this three bus system. The totally we have three buses. In the first bus is consists of a generator, and second bus also it consists of a generator. Whereas in the third bus it consists of sun compensator and flow. And these three are interconnected. This diagram is again converted into, or you have to draw the equivalent circuit for this first diagram. For that purpose, we are adding a current source parallel with the admittance. And for generator G1, the current is considered as I1, and admittance is considered as YG1. So it should be connected in parallel. So here I have connected I1 and YG1, and in second bus also we are doing the same. In second bus also we are doing the same. That is, we are connecting I2 bus with OG2, and we want to connect the first bus with the second bus with the admittance. So all the elements should have admittance. Okay, and so for connecting bus number 1 and 2, we are connecting an admittance value Y.2. And while going to the third bus consists of a sun compensator and a load. So each element has an individual impedance. So we have to connect the individual impedance. So the capacitor is in every capacitor has an impedance value. That value is connected as Y300, whereas load is connected as YT3. While comparing with the first and third bus, we have to connect another one impedance. We are talking about the right hand side diagram. So we are connecting first bus with the third bus with an impedance. That value will be Y13. We are considering it, its notation. So Y13. Whereas for all the transmission lines having an offline charge admittance, so we have to connect a offline charge. That is, it should be in sun format. So we are connecting a sun admittance as Y13 dash for all the buses. So totally, we in this network we have four uh, half line charge admittance. That is Y13 dash, Y13 dash, whereas Y23 dash. That is 2 3 is nothing but the line connected between 2 and 3. Where is the Y is the admittance and Y dash is the half line charge admittance, and YD is the admittance represented for load. For load purpose, we are representing as YD. So I hope you have understand how we are writing the equivalence of circuit. So in this formation, uh, that is in this circuit, we have considered a three bus system. That is three bus system. Three bus means totally we have three different buses. That three different buses are connected together and form the equivalent power network. that is right answer diagram. So it's a equivalent power network. What is the purpose of equivalent power network? Is we have to mention the admittance value in that network. Okay. From this, we have to form the matrix, Y plus matrix. For that purpose, we have to do for Kirchhoff's current law. What is Kirchhoff's current law? That is that incoming current is equal to the outgoing current. So, in the consider the first node, that is first bus. We are considering the first bus. In this first bus, the incoming current is I1 and outgoing current is all. So we are taking as I1, that is C at the right hand side, that is I1 is equal to, we have to write the voltage drop. Then what is the voltage drop? That is now generally we know that I is equal to V into R. So here we are using an admittance, so V into Y. So consider the first bus. What is the generator bus? We have a YG1. So we have to wait that YG1 should be multiplied by V1, that is voltage V1. Only the bus voltage, that is first node voltage, that is VG1 into V1. And consider the second line, that is bus between 1 and 2. We have to consider all the first node. So in that, consider bus number 1 and 2. So 1 and 2 we have Y12. So substitute that only 1 2 here, that is Y12 with the initial voltage is V1, that is bus number 1 voltage minus bus number 2 voltage. So we will get Y12 is into V1 minus V2. And then check what are the other buses are connecting with the node 1. Now here we are, I am saying that the bus is connected between 1 and 3. So again we go out to that. That is we can write that Y13 into V1 minus V2. That is voltage in the first bus minus voltage in that bus. And see another one thing is offline charge admittance. It's also connected with the bus 1. So we have to consider first off. So that is Y13 dash into V1. Okay, we are rearranging this equation with V1, V2 and V3. So by rearranging it, you will get the final value. V1 is multiplied with YG1 plus Y12 plus Y13 plus Y1 dash minus V2 Y12 minus V3 Y13 is equal to I. That is equation number 3. Again, we go for a second node. The same procedure should be repeated. The incoming current to the second node is equal to outgoing current. Here, the incoming current is I2. So, I'm considering I2 is equal to the admittance YG2 here, G2, Y23, and Y12 and Y2 dash. Totally 1, 2, 3, 4 elements we have to consider. So first element is multiplied with V1, that is Y1. YG2 is multiplied with V2 plus Y12, that is considered the second element, that is element from 2 to 3. Y22 is multiplied with V2 minus V1, that is voltage in the second bus minus voltage in the first bus. That is we are considering the second node. So we have to put the frequency as V2 at first, and we have to multiply with V1. So V2 is multiplied with V1 into Y12. And consider third element Y23. Y23 means it is connected between bus number 2 and 3. So here we have to multiply Y2 with 2, 3 with V2 minus V3. This here I have inserted, and add with offline charge impedance. So offline charge impedance value is Y23 and as Y2. Again we have to rearrange this equation as V1, V2 and V3. That is we will get minus V1 Y12 plus V2 into YG2 plus Y12 plus Y23 plus Y23 dash minus V3 into Y23 is equal to I2. from this we can I have considered as equation number 3.4. Again, we have to consider the node 3. So here the spelling is nodes is node. Okay. Consider node 3. In this, we have totally how many elements are there? Is 1, 2, 3, 4, 5, 6 elements are there. Okay, we have to consider 6 admittance. So again, we start from the first value is the capacitor, that is Y3 Y3 R. We are considering Y3, that is load admittance. So this load admittance is multiplied with the voltage V3. Again, capacitance voltage admittance Y3 not also be multiplied with the V3. That is mentioned here. That is Y3 plus Y3 not V3 plus, and we have to consider other element, that is the element between 1 and 3. 1 and 3 means Y13. So Y13 is multiplied with the V3 minus V1. Okay. After having one line charge, that is one line charge, that is half line charge is Y13. That's what we multiply with V3. And sorry, and consider the next element. That element is connected between 2 and 3. So Y23 is multiplied with V3 minus V2 plus, in that line having a half line charge Y23. So that value also be multiplied with V3. So we have to consider all the elements. So there is 6 elements we have to consider totally. And from this we have to rearrange the equation with V1, V2 and V3. We, after rearranging it, consider as equation number 5. From these 3 equations, we can form a matrix. That matrix is 3 cross 3 matrix. For each node, we have to form the matrix. If we are considering 2 nodes, then the output will be 2 plus 2. If we are considering 4 nodes, the output matrix will be 4 plus 2. Here in this, we are considering 3 elements. So automatically we can say that the matrix will be 3 plus. So from this, I'm going to write the consider equation number 3, 3.3, 3.4, and 3.5. So from first 3.3, from the equation of 3.3, we can write the first column of the matrix. So first column means it's nothing but we have to write this V1 value, V2 value, and V3 value. That's it. You can Y1, Y2 plus Y1 plus Y2. And in the second column, we have written the minus Y1, that is here, minus V1. Yeah, Y1. And that column we are writing 1, 3. In that we have to mention minus. Like that we have write the again go for the equation of 3.4. In 3.4, here also V1 value, that is first row should be written as Y12, and second is written as Y32 plus Y12 plus Y23 plus Y23 as, and that is considered as minus 2, 3. That is, yeah. Okay. Like that we have to fill the matrix, and we know the value of admittance, that is admittance into voltage is current. That's why we are writing the matrix as admittance with that voltage. Totally 3 buses, so totally 3 buses are 3 voltages are available. That is V1, V2, and V3. And is multiplied with current. Here I am taking as I1, I2, and 0. Why the 0 is come here is because only bus number 1 and 2 has a source that you can see in the diagram. The source is nothing but generator. Here bus number 1 and 2 have the source. So from this source only the current will produce. So we are considering I1, I2 only. And the third bus, there is no source at all there. It consists of one compositor and the load. So there is no sources. So we are considering I as 0, I2 as 0. Okay. From this, we can write the general equation, that is a normal matrix equation. y11, y12, y13, y21, y22, y23, y31, y22, and y23 is what I'm doing. y1, then it becomes I1, I2, and 0. For this circuit, if we are considering a generator and the data bus means we have to put it here as I3. Consider it. Where there is a center developing, that is where YII is equal to the sum of the elements of the element connected to the I node, whereas YIJ, that is I1, IJ, sorry, YII is nothing but considering a single node. Okay. YIJ means considering a two node. So YIJ is equal to the negative of the sum of the elements of an element considered between the node I and Yij is equal to 0. In case Yij is equal to 0, there is no line is connected between I and J. It's a simple thing. It's okay. And if we want to add some admittance or admittance to any network or any node, if we want to add an element of admittance to one node between two process, that is I and J. And consider the addition of lines. So here I am adding an admittance Y is connected between I and J. If we want to add an element, we have to add that element, that is that admittance with the diagonal value, and remaining value should be subtracted. That is, in a matrix there is a diagonal and remaining is a non-diagonal values. So if we want to add an element, we have to add that element, that is it's admittance. If we want to add an admittance, we have to add that admittance to diagonal values. Diagonal values should be added with that element. And remaining element, remaining non-diagonal values should be subtracted with that element. You can say that is here mentioned, that is YIA new. S is nothing but is equal to YIA volt plus the given that is added element Y. So all the elements having the sorry, we are considering only the arguments. Okay. So please keep it in mind. For adding any element to a node or in a network, you have to add that element to the arguments value for a diagonal value. Whereas for non-diagonal value, you have to separate the data. Okay. So here I mu is equal to Y I volt plus Y, and Yij mu is equal to Yij volt minus Y, and Yji mu is equal to Yji volt minus Y, and Yjj mu is equal to Yjj volt plus Y. In this Yi mu and Yjj mu are the diagonal value, and Yij and Yji are the non-diagonal. So in diagonal way I am adding it, and the non-diagonal way I am subtracting it. For removal of lines, in case we want to remove any elements from the network, means we can remove it, no problem. But you have to subtract that. While removing it, it's just a reciprocal of adding lines. So here we have to subtract with the non-diagonal values, and we have to add in the non-diagonal values. That is Yii mu is equal to Yii volt minus Y, whereas Yji is mu is equal to Yji volt plus Y. So consider just look at the above equation or convert the above equation with this. You can clearly understand that for adding purpose, the diagonal values should be added with that element. Whereas moving the line means we have to subtract the arguments value to the diagonal value. Okay. If we have to add the element, that is sun element, that is connected, that is I have already said that line charge algorithms. By that we are adding some line charge algorithms. It's just you have to add the diagonal. Okay, don't consider the non-diagonal. You want to consider non-diagonal values. You have to consider only the diagonal. So in that we have to add that element with the diagonal. That is why mu is equal to Yi plus 1. In case Yjj mu is equal to Yjj volt plus 1, you have to consider the diagonal value. That's all. Here we have some of the applications of Y-bus admittance. Just think about it. That is, Y-bus is used in solving load flow analysis in load flow analysis, Wipers is very much important to solve problems. Okay, and it has gained application over to specific in data preparation. For data preparation, it has high amount of tables. Okay, it can be easily found and modified for any change in network. It can be easily found. It can be that we can modify the circuit at any time. Okay, and it required computer memory and time is very less. So it takes only that is memory size can be reduced by using OE bus matrix. Okay. So some of the applications, just gone through it. A lot of applications are available. Just to go through it. If you have any doubt, you can contact me after getting. Okay. Okay. This still now we have seen about the theory part of the OE bus matrix. From this, we have to form the Wipers matrix. For that, we go for some of the problems. In gate-oriented questions, most of these are problem-oriented. So, for solving the problem, we have to know some of the techniques or tips to solve the problems. For that, we go for some problems. Okay. So, first problem is noted. Three-phase transmission line has 230 kilovolt, 300 MVA, 200 kilometer lines after symmetrical type. Find the bus admittance for the two bus system. Assume R is equal to 0.073 ohm per kilometer and L is equal to 0.45 per kilometer and C is equal to 1.6 nano farad per kilometer. Just please understand that while solving the problem, you have to read out the 3 or 4 times. Then only we get what they are expecting from that question. Okay, that is in get find out you have to read 2 or 3 times. Then only you can analyze what they are expecting from that question. After that, you go to the solving and solve. While solving it, it is easy. It's nothing but not able to understand the question very deeply. Okay. So read it 2 or 3 times. But you have to think about it and also but, do it fastly. That's all. Okay. So here the given values resistance, inductance, and capacitance, and then they given the value of voltage, power, and transmission lines length that is 200 kilometers. Okay. Here, consider R is equal to 0.073. Okay. You have to multiply that 0.073 into that kilometer. That is 200 meter. Why? Because in the question they have given us ohm per kilometer. Okay. That should be converted to more ohm per phase. So to convert ohm per phase, we have to multiply that uh, a symmetrical line with this resistance, that is R is equal to 0.073 into 200. So we will get 14.6 ohm per phase. And for all the elements we have to do it, consider the inductance L. So if the inductance L value is 1.45 millihenry, the millihenry is multiplied with 10 power minus 3, and you can multiply with transmission line length, that is 200 kilometer, that is we will get the final answer as 0.29 Henry per phase. We are converting everything into phase. Okay. And so after finding the inductance value, we have to convert it into reactance. So reactance XL for inductance is XL is equal to omega L, where omega is equal to 2 pi F. Omega is the angular velocity. That can be converted to 2 pi F. Omega is equal to, so 2 pi F into L. Where F is the frequency, we know that is 50 Hz. So here we have substituted that value. That value that is equal to 2 pi to 50 into 0.2. Finally, we will get the answer as 91.106 ohm per phase. Do it fastly and note it fastly, students. If you have any doubt after completing the session, you can ask. Okay, or you can ask personally. No problem. Okay. Then we have to consider capacitor C is equal to 11.6 nanofarad per kilometer. That nano is converted to micro, so we are multiplied with 10 power minus 3, so we get 0.0116 into 200, then we will get the final answer 2.32 microfarad per phase. That value should be converted into reactance. So reactance Xc is equal to 1 by omega c. In inductance, we have to multiply in the denominator, whereas in case of OC, it's reciprocal of inductance, then we are mentioned as 1 by omega c. So where omega is equal to 2 pi f, that already we know that is multiplied with capacitor, we will get 2 pi. Uh, so finally, we will get the answer as 13,137 ohm per phase. So that three values, okay, we will find out for the three values. And again, we go for a base MPA. That base MPA, we have to find out base MPA. So for that purpose, the given value 300 is multiplied with or divided with 3. So we get 100 MPA per phase. I said already we have to convert everything into phase. To convert phase, we have to multiply that 300 with 3 for power. Whereas in case of voltage, we have to multiply 230 voltage with 2. So finally we get 132.8 kilovolt per phase. So it's a common thing. And now we have to find out base admittance. So to find out base admittance, we have to it has a formula, that is base MBA divided by base KB square. So that is based in the base admittance is OIB is equal to the given data is that we have found out in the previous value, that is base MBA value is 100 and base kilovolt value is 132.8. Substituting this formula, that is OIB 100 to 132.8. After substituting, they will get 0.057 mho per phase. It's not a mho, it's a mho. Okay. Because we are considering automatically the formula is that is the unit is changes mho for admittance. Unit is mho. Okay. OHM for mho for resistance, whereas admittance is mho and mho. Okay. That's the next OH series. Okay. Consider an admittance series admittance. So we know the formula. This admittance is nothing but for the reciprocal of impedance. So Y is equal to 1 by Z. So OH series is equal to 1 by Z series. That is equal to we know that Z is nothing but that is impedance is nothing but resistance plus reactance. So here we are mentioning as R plus J XL for inductance. Okay. So we can write the formula as OH series equal to 1 by Z series. So 1 by R plus J XL. Already we have found out the per phase value of R and XL. Substitute that formula, that value. R value is 40.6 and XL value is 91.106. It is in rectangle for if you want, you can convert it to polar form, or you can solve it in the rectangle form. But kept in mind, or if you are going to solve means once you convert everything into rectangle or convert everything into polar, then solve it problem. Otherwise, it will get big confusion. Okay. Here I have converted into polar form, that is 14.6 plus J 91.106 is converted into polar form, and I get the answer as 92.26 at an angle of 80.85. And now I have divide this value with 1 and we will get 0.0108 at an angle minus 80.856. That value is converted to this value is converted to rectangle. We will get the value of 0.017. Yes, 0.6 mho per phase. I said already mho by unit of admittance. Again we see what we have to convert this into per phase. So we have to convert into per phase. We have to multiply with base admittance divided with we have to divide it with the base admittance. So Y series per unit is equal to y series value is divided with base admittance. So here I am substituting the values 0.0172 minus j 0.0107 by 0.057. That is equal to uh, 0, 0. And finally, we get 0.3044 minus j 1.88 per unit mole per piece. Okay. So after everything, we have to connect with the per piece. Okay. Next, line charge admittance OEP is nothing but a minus of 1 by x. We have to consider minus for the line charge admittance. OEP is equal to minus of 1 by x. So substitute that xc value, that is minus 1 by j, that is fine, and 1375. And we will get the final answer and answer as j 0.727 into 10 power minus 3. This is a line charge admittance. Offline charge admittance, that is, it's a half, means it's half, that is divided by 2. We have to divide this value with 2. So finally we get OEP by 2. That is finally we have to multiply this value with the 2. Then we get the value as j equal to j 0.000364 ohm per phase. Okay. Then again we have to convert into per phase. So per phase offline charge admittance is nothing but the offline charge admittance is divided with the base admittance. So again we will get we substitute this value in this formula, that is j 0.00364 is divided with the base admittance value, that is 0.0057. So finally we get j 0.0638 per unit mole per phase. Okay. So okay, after finding all these things, we have to draw the sequence network, that is sequence circuit network. Okay. So this sequence circuit network is drawn from the given paper here. The given diagram. Given the diagram as it consists of 2 buses, and 2 buses are connected with an transmission line, and each transmission line has an offline charge. Okay. So that is I am mentioning here. First 1 and 2 are connected with the transmission line, and each transmission has one admittance, that is considered as y series, and transmission line has 2 offline charges, offline charge admittance. So that is considered as YP2 by 2 and YP2 by 2. Okay. There is no source at all. You can see in the given data that there is no source. There is source is generator. They doesn't mention any generator. If they mention any generator, means we have to consider the voltage or current. Okay. So after drawing this sequence circuit, from this sequence circuit, we have to form the matrix. That is that we have already seen in the theory part. So I'm going directly into it. So consider y11. So normally y1 and y22 are almost same. So here I'm taking as equal. That is y11 is equal to y22 is equal to. Consider what is the element occurring between y1 and 2. Already I said you have to consider as current development. Okay, anyway, consider what are the elements are connected between 1 and 2. There is only one element, that is y series. So consider y series plus, and it has an offline charge YP by 2. So plus YP by 2. Substitute these 2 values. That is we have already find out that value. Substitute in this equation, we will get y series value is 0.3044 minus, YP value is j, that is 0.3044 minus j 1.88 is the value of y series, and YP value is j 0.0638. After substituting it, we will get a final answer as 0.3044 minus j 1.88. Yeah, this is a diagonal value. I said already YIE and YJJ are also diagonals, and non-diagonals are YIJ and YJI. Such I is equal to 1, then we will get YI11. If we substitute I is equal to 2, then we will get Y2. Okay, anyway, so the diagonal value is 0.3044 minus j 1.88. and we have to consider non-diagonal value also. So non-diagonal value is O1. So O1 is the elements is connected between 1 and 2 is only one element, that is O series. That is denoted by minus, that is O series is one. So first the value directly, that is minus 6.3. So plus substitute these two, from these two equations we can form the Y plus matrix. The Y plus matrix we know the formation, that is Y11, Y12, and Y21 and Y22. That we already studied. Just substitute that value in this corresponding area. So finally we get the matrix of 0.3044 minus j 1.34 minus 0.3044 plus j 1.33 and minus 0.3044 plus j 1.33 and that is y22 is 0.3044 minus j 1.33. From this we can form the Y plus matrix. Okay, so in J generally Y plus matrices are very important in J example. Okay, we'll see some more problems. Okay, okay. Here they said that they are adding only one capacitor to the bus. That is, we have to consider the previous sum. In that sum, they are adding some capacitor. That is, the shunt capacitor C is equal to 1.59 millifarad. This farad is connected to the bus 2. Yes, a shunt capacitor C is equal to 1.59 millifarad is connected to bus 2 from the new admittance matrix for the previous example. Here you can understand we are adding an element. We are adding an element considered. Okay, that element is connected in bus 2. You have to consider the previous sum. In that previous sum, we are adding a capacitor or we are adding an element to the bus 2. So for adding the element, I said already we have to connect it with the we have to add it with the admittance. Okay. So first we have to change the value of capacitance in the admittance. That is the capacitance value SC, that is 4.59. Yes, multiplied with omega. That is omega is 2 pi. Square f is the frequency, that is what we have. Just substitute the value and find out y2 naught. So y2 naught is equal to j omega c is equal to that omega is replaced by 2 pi f. So a 2 pi f into the given value 1.59 into 10 power minus because it's 10 milli. So finally we get an answer as j 0.5. So this j 0.5 is added with the second bus. Okay, you can see it here because the capacitor is connected only in the second bus, not in. If it is connected in 1 and 2 means we have to consider everything. If in this sum they are considering only this second bus, so second bus, so we can add that as a value in only in this second bus. Okay. So from the previous sum answer, that is Y bus matrix is taken into account and adding that this value. Okay. So Y22 is added with Y2 naught. So just go to it. Yeah, I'm writing the same formula. That is same answer what we get from the first form, and adding that I'm adding only j 0.5 in Y22. So here we can see. So Y22 value is 0.3044 minus j 1.88 is added with this capacitance plus j 0.5. So finally we get an answer as 0.3044 minus j 1.1. Okay, this is a main thing what we have to if we added the element, we have to add in the diagram. Okay. Okay. Here they are sent some notes. These are, okay. We'll see some other. Just note this problem. Determine Y plus matrix for the given for the data given below. Okay, we want to form the Y plus matrix. Same, we want to form the Y plus matrix. They given the value, that is reactance value. They are given. So reactance is nothing but X. So we have to for if they given the reactance means so reactance, we have to, it is a impedance value, that is Z is equal to R plus J X, where here they have given us X, where R value is considered as 0. So from this given data, we can consider the given values and impedance value. So that impedance value should be converted to admittance. It's very simple. Admittance is nothing but the reciprocal of impedance. Okay, ESEC. Okay, here they have given the value of ESEC. Okay. Okay. So here you can see from this diagram, from this table account, we have to draw the diagram. Okay. That's we have to draw the equivalent network. Uh, Here concept of total how many buses are there? Just coming out 1, 2, and 3, and 4. Total 4 buses are there. So we have to draw a 4-bus system. So output will be 4 plus 4. I said already. Based on the buses or nodes, only we can say the matrix forms. If it has 3 buses, and output will be 3 plus 4. Here we have considered the here it has 4 buses, so the output will be 4 plus 4. Okay. So consider first bus, that is from bus number 1 to 2. So we have to talk over nodes, that is node 1 and 2 is connected with an impedance value, that is impedance J 0.2. So first I have drawn first bus with the second bus. I am connecting first bus with the second bus with an impedance value of J 0.4. And then second bus is connected with that bus with an impedance value of 0.1. Here I am drawn. Second bus is connected with that bus. Their impedance is J 0.2. And can think about that line, that is first bus is connected with that bus. So first bus is connected with that bus, and their impedance is J 0.3. And consider okay, consider fourth line, that is bus number 3 is connected with the fourth bus. So bus number 3 is connected with the fourth bus and consider as impedance as J 0.4. Then the thing, last 2 lines, the from value is 0 and to value is 1 and 3. What it means is you have to consider only the offline chart, that is it is only belongs to that bus. So bus number 1 is connected to 0.6, that I have mentioned as inductance because it's an impedance 7. Yeah, impedance, sorry, connector and inductor, that is J 0.6. And same is repeated in bus number 3. I'm connecting an inductor. Other end of the inductor is bounded for stability. The value of value is J 0.8. We have to draw this diagram. Once the problem is given in table count, you have to draw the equivalent network. Otherwise, it is very difficult to solve the problem. Anyway, you can solve it, but it is easy. So simply draw the equivalent network. After drawing it, we have to form the matrix. So for formation of matrix, I said already. Consider first node. So in what are the elements are connecting in the first node should be considered in Y11. Okay, in Y11, what are the things are there is they given a notation, that is 1 is Y I0, and next impedance is Y 1 2, and the third one is Y 1 3, and second column is nothing but minus Y 1 2, and third is minus Y 1 3, because no other elements are connected between 2 and 3, and sorry, 1 and 2 and 1 and 3. Then go into the second column. So second column is second 2 bus, that is second bus. So in this second bus, the total how many elements? 2 elements are available. Yeah. Okay. So first you have to consider Y21. So in between 2, it is considered as minus Y21, and second is Y22. In Y22, totally 2 elements are connected. That is Y12 and Y23. That I have. Yeah. And that Y23, we have to write that as minus 3. and there is no element is connected between 2 and 4, so it is considered as 0. Even in first bus also we have to consider as 0 because there is no element is connected, there is no touch with the fourth bus. Okay, so we have considered as 0. Okay, next consider that bus. In that bus, we can write it as y13, there is only one element, and y minus y32, there is also only one element, and y33. In y33, totally 1, 2, 3, 4 elements are available. So we have to consider that 4 elements, that is y3 naught plus y1 plus y32 plus y, and y34. In y34 it has one element, so minus y34. Now we consider fourth bus. So in fourth bus, y41, there is no connection between 4 and 1, so I consider 0. And y42, there is also no connection, so I consider 0. Then y43, there is an element, so we want to consider minus y42. And y44, in y44 it has only one element, so again I consider y43. Substitute this value in the corresponding matrix, that is y10. Here I said already the given value is impedance, so we have to take it as reciprocal for admittance, because we are considering here is admittance. Y is nothing but y is equal to 1 by z. So in the given data, they are given as impedance value. So to convert that impedance value to admittance value, we have to take the reciprocal. That's it. Okay. In 10, the value of 10 means 1 and round. The value is 0.6. Okay. So I am taken as 1 by 0.6 plus what is the value of y12? Value of y12 is j0.4. Okay. On this diagram, just go through the diagram. Yeah. Okay. So value is 1 by j0.2. And then think about the y13. What is the value of y13? It's yeah, j0.1. So substitute that j0. That is a j0.3. Substitute that j0.3 here. So 1 by j0.3. Like that, fill this matrix, that is minus y12. You know what you want to value is j0.2. Okay, so back to, and the minus 1 3 is minus 1 by j0.3. That is taken from the diagram. Okay, that is y1 for value 1 for there is no connection, so I'm putting as 0. Uh, then we'll go to the second, that is minus y1 to second row. So second row we have considered as minus 1 by j0.2. And y12 is the formula 1 by j0.2, y2 2 3 value is 2 j0.1. So here I substitute as 1 by j0.1 and minus 2 3. So 2 3 values 1 by j0.1. I have to put 3 minus except non-diagonal one is all the non-diagonal is multiply with the minus 1. So consider the third row. So in that row, we are considering as minus y31. What is the value of y31 is j0.3. So minus 1 by j0.3. Minus y32 values minus 1 by j0.1 and y30. Okay, consider y30 value is j0.8. So substitute that j0.8, 1 by j0.8 plus 1 by j03 plus 1 by j0.1 plus 1 by j0.4 and y34 values 1 by j0.8. By this we have to fill the matrix. After filling it, substitute all the values, we will get a final answer as y plus 6 to j10, j5, j3.33, 0, and the second row consists of j5, that is minus j15, j10, and 0. Third row is considered as j3.33, J10, J minus J 17.08, J 2.5. And fourth row is considered 0, 0, J 2.5 and minus J 2.5. Just look into the final answer. All the diagonals are having negative sign, okay, whereas non-diagonals or diagonal values are having a positive sign, okay. So from this, we can form the wave perspective. I hope that you understand something. Okay. Okay. Here, one sub. Here, in this, we have to consider the same clear sum. In this, we have adding an impedance value in between the first two and three. Just read out here something. In this example, consider the example 3.3. Add a line between the impedance 0, uh, 0 plus j 0.5 between first two and three. That impedance value 0, that is j 0.5 is added between first number 2 and 3. They are adding an impedance value after between first number 2 and 3. Okay, that is in this network we are adding additional impedance in between the value between the buses 2 and 3. Okay, so we have to consider the same matrix. That is the final answer should be considered. In this, we have to change small molecules. Okay, here clearly they mentioned that a new impedance value is added between 2 and 3. So we have to consider only second bus and third bus. Okay, so second bus is we know that y22 and third bus is y33. What is the relation between second bus and third bus is y23 and 34. Okay, so I said already in diagonal value, that is y22 is diagonal, y33 is diagonal, whereas y23 and 32 are not diagonal. So diagonal values should be added with the new because we are adding the impedance. If we are removing the impedance, we have to minus. Okay, so in diagonal value, we have to add the impedance value. So totally we have to change only four elements in that matrix, that is y23, y22, y32, and y3. So in this y22 new, we have considered new y22 new is equal to y22 volt, that volt value is taken from the matrix is added with the new element y. Okay, so the from y22 is minus j 15. That is minus j 15 is added with this value j 0.5. That is its impedance value that should be converted to admittance. So for that admittance conversion, z is equal to j 0.5. Then y is equal to 1 by z. So 1 by z will do 1 by j 0.5. Then we will get as answer as 1 j comes off. It's we should put minus equal, so minus j 2. Okay, that value is added with y22. So if j minus j 15 plus j 2, that is we will get a j 7. Okay, then go to the next node, that's y23. We know that y23 and y32 are same value, so consider as the same. This y23 minus y. So y23 volt values j 10. You can see it in the previous answer. That is j 10. That j 10 is subtracted with the given impedance. So that's j 10 is subtracted with given impedance j 2. So j 10 minus of minus j 2. Then we will get as j 4. Okay. Then go to the next element, that is y33. The y33 volt is one of the diagonal values. It's added with that impedance. So that arguments y33 volt plus y. So y33 value is j 17.08. That is taken from the previous sum. Is added with j 2. So we will get as final answer as minus j 19.08. Now just replace these three values in the previous final answer matrix. That is, we have to replace y22, y23, and y3. These four things only get changed. Okay. Alright. So after we have to change that four elements only. So remaining things are the same. So from this we can find the y plus mu. If we want to add some meters, we can go this method. If we want to remove that element, it's very simple. We have to put here that is a diagonal value should be subtracted and non-diagonal value should be added. Here we have added it. For the adding purpose, we have added the element with the diagonal value and subtracted with the non-diagonal. For removing the element, you have to subtract the value with the diagonal value and add the element with the non-diagonal. That is the keep it format. Okay, next. For the network shown in figure, write the element of y bus matrix directly by inspiration method. Inspiration method are uh, inspiration method are two rule method are same. Okay. Actually, I have said in the first example, the two rule method is otherwise called inspiration. Okay. Uh, Here they are given a circuit. So first of all, we have to uh, do one thing, that is if in any circuit having the current source means it should be open circuit. If any circuit having voltage source means it should be open circuit. Here they are given two voltage sources. That voltage source should be open circuit. After open circuit, we have to mark the node. So first I'm moving these two voltage source. Yeah, remove it. After that, totally I'm considering three nodes. That is here one node, two, three. And the reference node has taken as zero. Okay, that's not here. Anyway, so totally here we have three nodes. So what is the output? We will get definitely we will get a 3 plus 8. Okay. Okay. So to form Y bus matrix, we know the formula y11, y12 is a general formula. So from this, we have to find out the value of y11. What is y11? Again, go into the cycle. What are the elements connected with 1 is considered as y11. What are the elements here? 1, 2, 3. Three elements are connected. So these three elements should be added. Okay. Yeah, that is what are the elements are j minus j10 minus j0.5 and minus j20. Here they are given directly. Directly the admittance values are given directly. So there is no need of taking reciprocal. Okay. Uh, so just note it out. We have to add j10 plus minus j0.5 minus j20. So here I have added and consider y12. So what is y12? Node number 1 and 2. The element at the presence in between node number 1 and 2. In 1 and 2, it has only one element, that is j 0.5. J 0.5. Next, y13. So 113 is connected with the node element, that value is j20. Then go into the next topic, that is y21. So 21 value will be equal to 12. So 21, I am taking the same value. 212 value, 12 value is j 0.5 is considered as j 0.5. I am taking the same value. Okay. And y22, again go into this y22. In y22, how many elements are connected? In second node, totally 1, 2, 3, 3 elements are connected. So these three elements should be added. That is j 0.5 plus j1 plus j 0.4. These three elements should be added. These three elements should be added and added. Okay. So okay. These three elements should be added. So So we will get a j 10 minus j 0.5 minus j 0.5. And add y32. In y32, it has one element, that is j 0.5. So just substitute j 0.5. And go to the third row, that is y31. So y31, we have the value as 31. One value, that is j 20. And then 32, we have one element j 0.5. You can see it, y32 and 3, 2, 3 are same. Like that, 1, 2, sorry, j31 and 1, 2 are same. You can see it in the no? So I go directly into the y33. In y33, totally 1, 2, 3 elements are connected. So three elements will be added. That is j20 plus j 0.5 plus j10. That's nice. So we get the final answer as minus j 30.5. Okay. From this we can form the matrix. So final matrix value is y bus is yes minus j 30.5, j 0.5, j 20. It's everything is comes from this above equation. Just solve that equation and get the y bus matrix. It's very simple, and these types of sums are asked frequently in GATE exams for 2 marks. Okay. Uh, Totally still now I have gone through 2 sums in GATE question paper. What is the difference between previous sum and this sum? In previous sum they given the direct admittance value. Okay. Sorry, yeah. Here they given the impedance value. So the impedance value means we have to take as 1 pi. That's all. We have to take this. Just note this problem. From this, yeah, go to the problem. For the network shown in figure, write the element of the bus admittance matrix directly by inspiration. They are given a circuit. I said already order. If voltage source is given means we have to open circuit. If current source is given means we have to short circuit. So here this wrongly mentioned. Open circuit should be open. I know for voltage source it should be open, and for current for current source it should be open, and for voltage source it should be short circuit. Here they have given the voltage source, so it should be short circuit. Okay. First, we have to short circuit the voltage and voltage source, and consider the node. How many nodes are available here? 1, 2, and 3. So totally 3 nodes are available. We have to take into account. That is first node, second node, and third node. So from this, we can say that totally three cross tree matrix we are going to form. So what we have seen already. So consider this network. We have to consider y11. So in y11 totally how many elements are connected with the y11 means totally 3 elements are connected. That 3 elements will be added. Here we have to take a reciprocal because the given value is impedance value. That impedance value is converted to admittance. Why? That is to convert admittance we have to take reciprocal of impedance value. This was final answer is 1 by. We have to take as 1 by. Okay. So consider the first element. This element is of 3. The first node. Consider first node. It consists of 3 elements. That 3 elements will be added. Then go to the second place. That is y12. That is in y12 there is only one element. That element is considered. That element is j.3. That should be reciprocal. You have to take reciprocal. That is 1 by j 0.5. For a non-diagonal value, you have to mention minus symbol. So I have to mention. And next, y13. There is no connection between y1 and 3. So we have to consider there is no connection. There is no element at all. So we have to consider 0. Okay. Then go to the next row. In next to y21. So y21 under that 2 1 and 1 2 are almost same. So uh, always 1 2 and 2 1 are the same. So we have to take the same value minus 1 by j 0.5 and y22 value is in second node. Just to go through that diagram. Totally three elements are connected with j 7 node. Consider that three elements. That value is 1 by j 0.5 plus 1 by j 1 plus 1 by j 0.4 and y 3 2 there is connection with the 3 and 2, so 3 and 2 that is j 0.4, that j 3 0.4 is taken. We have to take the reciprocal as 1 by j 0.4 and go to the next row, that is that row. That row means y3 1. So there is no connection between 3 and 1, so consider 0. And 3 2. So 3 2 value is already we known, that is minus 1 by 0.4. We have to take it into account. And y3 3. In 3 3 totally 1 2 and 3 elements are connected in it. So we have to add these 3 elements, that is j 0.4 plus j1 plus j 0.1 with the reciprocal. Okay. So after noting note after after solving it, we will get a final answer as y bus is equal to minus j bracket j2 j0 j2 minus j 5.5 j 2.5 j0 j 2.5 minus j bracket 0.5. So from this uh, we can find out the y bus matrix. So it's a very very important sum for the get exam. So we'll stop the session today and we'll continue session on tomorrow.